had experience with using Qualcomm-based, ARM-based hardware encoders. So we had some good experience with that, and that made us look into ARM as well. In parallel, we saw the huge shift of AWS towards Graviton, which also is ARM-based setup. So there was a strong movement, and in the end, the success of ARM in the field of mobile devices was mainly because of the low power consumption. So that was something that made it very interesting to us. And besides, we had a couple of machines that we are using for certain servers. So we usually use CDNs, but for some of the protocols we don't get from the server. So like ancient IceCast streaming or MPEG-TS over TCP, we have our own CDN infrastructure that we built in Germany. And we have been using AMD EPYC processors for that. And we saw that they simply do not scale linearly. So if we add more and more load, it does not just work with more cores. At some point, it goes down. And with the ARM CPUs, especially with the 128 core machines from Ampere, we see practically linear growth with the number of cores. And that's very important for us, because if we have a system that works with live transcoding, we have a limited capacity in terms of the SDI inputs and of the NETINT cores that we have. And then we need it's easier to calculate if we know that the CPU is scaling linearly, as if we would have to calculate also the flattened curve.